So we are going to go over some new information today. Every day prior to this, we have been looking at just finding the Q1, the median, and the Q3, but now we are learning some other components of this, the mean absolute deviation and the interquartile range, and also just finding the mean as well. So the first thing we need to make sure we do is ensure that our data set is in order from least to greatest. It is not at the moment, so let's go ahead and fix that. So we will have 72, 75, 76, 76, oop, what that is, 76, 77, 78, 79, and 81. All right, so now we have that. So the first thing we need to do is figure out what our median is, or our middle number. We have 1, 2, 3, 4, 5, 6, 7, 8 numbers total. So we're going to be able to split this data set in half equally. There is no number directly in the middle that we can circle. So we know that we're going to have to add 76 and 77 together and then divide by 2. And that will give us 76.5 as our median. And then we know that we need to go back and label our quartiles. We have our lower quartile and our upper quartile, and these sections will allow us to identify our Q1 and our Q3. Our Q1 will be the median of the lower quartile. So we have these four numbers, 72, 75, 76, 76. The median of that is going to fall in between 75 and 76, giving us a Q1 of 75.5. And we will do the same thing with the upper quartile. We're going to split that data down the middle, and in between 78 and 79 will be 78.5. So that is our Q3. Now to find our interquartile range, all we need to do is take our Q3 and subtract Q1 from it to give us our IQR. IQR. So 78.5 minus 75.5 gives us an IQR of 3. Now, we can also go in and calculate what our mean is. The mean is the average of a data set. So to find the average, you're going to add all of your values together, and then you're going to divide by the number of numbers in the data set. So we know that that number is 8. So we're going to be dividing by 8 after we add all these values together. So we'll do 72 plus 75. After we add all of these numbers up, you will end up with 614, and then we're going to divide that by 8, and our mean is 76.75. Now, the last part, which is a little time consuming, but that's okay. Let's get in the habit of writing this stuff out all of the way so we can really understand what we're doing here. So we're going to write our data set up and down. So 72, 75, all the way through 81. And then we will have a column for the mean as well. The mean is the same for all of them, so write them out. Again, it's time consuming, but that's fine. Sometimes it takes time to get this math work done. And our last column will be representing what the deviation means, or what the deviation is, sorry. So we're trying to figure out how far away is the data point from the average, like how far do we stray away or deviate from the average of the data set. So from 72 to subtracting 72 minus 76.25 will give us negative 4.25, but we're looking for the absolute. That A in that acronym represents absolute, so we're not going to have any negatives in our deviation line, even if the answer you get after subtracting the mean from the data point, you have to make sure that your value is positive. So it's going to be 4.25. And then again, moving on, I'm going to go ahead and just complete this. All right, and now that you have the full deviation column together, we are going to try and find the mean absolute deviation. So we're going to calculate the mean of the data in the deviation column. These values will all get added together. So let's go ahead and do that. Make sure you are double checking your work. Mental math is great, but we want to make sure that we are accurate and 100% correct. So make sure you're using your calculators to double check, even if you did the work in your head the first go around. You should end up with a total of 16 after you've added all those values together. And we remember that we have 8 values within our data sets. We're going to divide that by 8. And 16 divided by 8 is 2. So our mean absolute deviation is 2. And what that means is that each of the data points are about 2 units away from the average that we identified earlier on. That is what that mean absolute deviation represents. All right, that's it.